Hi, everybody. Today I'm going to discuss arithmetic sequences, which to me, it seems really silly to talk about a whole new part of mathematics when they're really just a very specific part of functions. Um, Here's what happens. We've got these numbers and there's a pattern, and patterns in mathematics are usually described using functions. And I would prefer, instead of thinking of these sequences as a whole new thing, as thinking of them as just a special case of a function. Now, what they do is they say that this is A1, A2, A3, A4, and so on, and that there is something new and different going on here. But what I want you to notice is that they have what we call a common difference. And if you notice, there's a pattern going on here. Hopefully everybody can recognize that this is an arithmetic pattern. We're adding or subtracting the same thing over and over again. And the whole idea of sequences and the idea here is that we would be able to, for example, make a prediction, what would be A of 10. And we could, of course, write them down until we get to the 10th one, and then we would know what it was. Or we could use what we call an explicit formula. And finding that explicit formula would allow us to skip over all these and go to A10. A lot of people say, well, why would I want to do that? Well, clearly you don't want to write them all for A100. What I'm going to do today is I'm going to show you the way in which it's normally done, but I want to show you that it's the exact same thing that you already know. So here it is. Let's take a look. And I'm going to do these side by side. And I want you to notice that this is the same problem in both cases. But in the second one, it may look a little more familiar. This equation might look a little more familiar to you. Now, how in the heck why would we do all of this if we could do it using this one? And that's my question. So this is my first point. 8 is my first number, and 13 is my second number, and 18 is my third number, and 23 is my fourth number, and so on. What I'm suggesting is that instead of writing A1 like this, why don't some of you recognize that y is the same as f of x, and that we can use any functional notation we want. In fact, I could use a of x if I want for y. And so what I'm going to do is I'm going to write a of x instead of y, so that you see that there's a connection between these. Ax is equal to mx plus b. Some of you are aware that functions can be written with different letters. Well, I'm going to call this a of x. Well, this is a of 1, isn't it? And this is a of 2. And this is a of 3. And for those of you who know function notation, this is just the point 1, 8. And this is just the point 2, 13. And 3, 18. And 4, 23. Well, wait a minute. This looks familiar. I can take 2 points and find a slope, can't I? And what is the slope between those 2 points? The slope is y1 minus y2 over x1 minus x2. 13 minus 8 is 5 over 1. So my slope is 5. Now I still need my b, don't I? Well, remember, we choose one of the points. It doesn't matter which one. And I put it into y equals mx plus b. So I'm going to choose the point. I'm just going to pick the very first one, 1, 8. And I'm going to put that into y equals mx plus b. So then I put in the 5. The y is 8. The m is 5. The x is 1 plus b. And I'm going to subtract 5 from both sides. And we get b equals 3. So my equation is y equals 5x plus 3. But remember, I didn't want to use y. I wanted to use, let me call it a of x. Now, if I want a 100, for example, it's going to be 503. If I wanted a of 70, it would be 353, and so on. I could find my values as if they're functions. Well, guess what? They are. There is no difference between a1 and a with a little 1 subscript, except notation. That's the only real difference between them. Now, yes, you can go through this and put these numbers in. A of n is equal to a1, which is 8, plus n minus 1. Well, now you have to know that n is my x value, or in this case, they're using n instead of x. Now the d, you have to recognize a whole new constant, or a variable. D is the common difference. The common difference for these, we're adding 5, we're adding 5, we're adding 5. So the common difference is 5. Well, I'm distributing this, and I get 8 plus 5n minus 5. Well, this says a of an, I want to say a of n, is equal to 5n. 8 minus 5 is plus 3, isn't it? So, same. Why does this work? Well, the reason that this works is because it's a very special case. In fact, I did a general case over here, but notice that this is always 1, 8, and 2, 13. So the difference between them is really the slope. It's just the slope. And to get to the 0 term, I just went 1 back. Now, what gets really complicated is when you have a problem like this. A7, the 7th term of a sequence is 13, and the 15th term of a sequence is 29. Find the explicit formula and the first 3 terms using this weird formula again. And in order to do that, we would literally have to substitute into this thing. We would have to do a lot of reasoning and thinking and everything. But instead of that, why don't we just use the points and find the slope? So I'm going to use my points and find my slope. My slope is 29 minus 13, which is going to be 13 from 29 is 16. And 15 minus 7 is 8. And that's a slope of 2, isn't it? Now I'm going to substitute one of my points in. I'll use the 7, 13. So y equals mx plus b. And I'm going to put my y, which is 13, my m, which is 2, my x is 7, plus b. That is 14. So I'm going to subtract 14 from both sides. I'll go ahead and write it for you. So I need to subtract 14 from both sides, and my b is equal to -1. So my equation is y equals 2x minus 1, and I can substitute 1 for x, and I get 2 minus 1, which is 1. 2 times 2 is 4 minus 1, which is 3. And 3 times 2 is 6 minus 1, which is 5. There's my first 3 terms of my sequence. Here's my sequence. I'm going to call this a of x so that it looks like a sequence. I have no idea why anyone would choose to do this as a completely new topic. And so I'm going to leave it at that. I hope you can see that this is a much more effective procedure to follow. I already have my formula. If you want to write it like this, more power to you. This is going to be 2x minus 1, which is 2n minus 1, isn't it? And let's see if that works. Put a 7 in there and you get a 13. Put a 15 in there and you get your 29. Again, I'm going to recommend this method. So I hope that makes sense to you and you can see the connection. So I will see you back again. Bye-bye.